Hello, welcome to this vlog, and today we're going to be talking about factoring, and we're going to talk about the greatest common factor. What does it even mean? And if we have numbers here, we have 36, 54, 90 in our example here before you on the screen. Okay, I need to know what number is the biggest possible divisor for each of these numbers. Or is it a factor if I find a factor for all of them? Now, I have done some work before ahead of time. We have 36, and the factors are 2, 2, 3, and 3. What does that even mean? Let's talk about that for a second. Okay, so that the factors 2 times 2 times 3 times 3 equals 36. Now we have the same thing for 54 and for 90. Okay, all those are fully factored. Now we're talking about how to find one number that will divide all these numbers, 36, 54, and 90, and not only one number, but the biggest number. What we're going to do, circle the common factors. What that means is we look for factors that all three numbers share. We'll circle them, watch. Two, 2, and 2. They all have a 2 inside of them. We'll put that over here. The first one has a 2, but the rest of them do not. So 2, there's no other 2 in there. Okay. Now look at 3. They all contain a 3. Put that over here now. Now, there's a second 3. Okay, I circled the first set of 3s. Now a second set of 3s I'll be circling. What that means is the 2s are there, then the 3s aren't exactly in the same row, but it's still okay. Whatever they all have, you circle them. The 2s were all there, and then 3s were there twice. Now, if you look at the 5, not all of them have 5s. One 3 left for 54, but there's no more 3s anywhere else. So 2 times 3 times 3 will be 18. Now, 18 can divide all of these numbers evenly. And there does not exist a larger divisor. There are smaller divisors. You can divide them all by 2. You can divide them all by 3. You can divide them all by 6 or 9. Those will work. But 18 is the largest. Okay? Now here's our next example. Okay. Now, for these, we're going to write the factors out first for each term. The numeral part, the coefficient, and then the variable part. Okay, now we've fully factored each term into the smallest possible factors. They're all prime factors. There's no further division we can do. Now we have to figure out what matches across all three terms. I notice 2 is in each term. So 2, 2, and 2. That's easy. Now I look at 3. No one else has a 3. No one else has a 2, another 2. So you can say within our term, the number part's done. Now with the variables, we have A, and then A, and A. Now we look at the B's. The first term has 3 B's. The second term has no B's. The third term has 1 B. Now, since the middle term doesn't have a B variable, that means B cannot divide each term. So B is not involved in our GCF. But they all have a C. All right. Now, we're going to take our yellow and our green and our pink, or purple, whatever, and move it over to our GCF. Two a squared c is the largest possible divisor for these three terms. There's no remainder, there's no decimal, and whatnot. So here's our next example. So our polynomial here, we have three terms. We're going to work through the first term and factor it, second term and the third term. Okay? I quickly did this. 12 factors out to 2 times 2 times 3. Then for each variable, r squared is r times r, s is just s, t cubed is t times t times t. Okay, that's how we go with this process. I'm going to do the other two terms quicker. Now, my job is to find things that each term have in common and to circle them. I can see, let's look at the 2. Not all of them have a 2, but they all have a 3. So seemingly, they all have a 3. Let me look for something else. Nope. So now for our variable part of our coefficients. They all have an R. Now the S. I see S, then S times S times S, and then S times S. So we have one S in each of our terms. Now look at the T's. I see 3 T's, I see 2 T's, and then I have 3 more T's in the bottom. That means each of them have 2 T's for each term. Now, let's gather them together. Now, we have our greatest common factor. Okay, I can divide all of these terms. 3r st squared. Now, we have our terms to our polynomial. What we need to do, now it says remove, pull out. How do you do that? What it means is dividing each term by 3 rst squared. Watch. We're going to divide each term by 3rst squared. And we're going to use our exponent rules. And once we divide it out, we'll see what's left inside. Okay, you can see I cleaned it up. Once we factor out our GCF, what's left inside, we're dividing a 3r st squared out. We're pulling that out, and what's left is this. Okay, and that's our final answer right there. We can see if you want to check this, you would multiply the monomial back into the polynomial, and you should get back to our original equation. Thank you. See you next vlog.